Hey everyone, and welcome to the final lesson in Unit 1. So at the end of this, you will be able to progress on through the playlist, complete Module 2, take the quiz, and then there will be a unit test as well for Unit 1. So you should be totally prepared for that unit test by the end of this. Goals for today. We're going to look at writing the equation of a function based on a graph. So this is going to be an important skill that will apply to a lot of the functions we do. We're going to look at it for quadratics and absolute value today. Identify transformations on absolute value functions. So we've talked about transformations already, just can you spot them on an absolute value function? And then finally, we're going to solve absolute value functions for different given domains or range values. So how do I write the equation of a quadratic or absolute value function when given the graph? That's going to be a big question for us today. And then what are the steps to solving an absolute value equation? Today's going to be a little bit of a longer one today, so buckle up, let's do this. Last class was writing inverse functions. Remember, that was a four-step process. Replace f of x with y, isolate x, so solve for x, switch x and y, and then finally substitute f inverse of x instead of the new y value to get your inverse function. And we also learned that inverse functions are the reflection over the line y equals x of the original function. Okay, so first up is writing the equation of a function. So this is a really useful skill that when you're given a graph and you want to find out like, okay, what is the actual equation of this graph? And by useful, I mean, this actually does have application in real life as well. If you start plotting certain points and you're like, okay, I need a function to represent what happens if I extrapolate or interpolate this. So it's kind of like the regression function in your calculator, but a little bit more precise. So let's look at the quadratic. We're given 2 points, the vertex at 2, -3, and another point 1, 1, which is on the function. So identify the type. This is a quadratic. You should be able to identify it by looks in almost all cases. So just make sure you do that. If you were just given a tiny little segment of a quadratic, you might be thinking, oh, is it linear? Is it exponential? But most times you're going to be given enough to be able to tell. So we're going to write the general form. So general form, remember, is with all of those parameters still there. So we would say g of x, and we've got a parenthesis 1 over b x minus h. That's all to be squared because it's a quadratic plus k. So our general function for a quadratic. Now, because it's quadratic and there's really no way to tell the difference between A and B, so a vertical stretch is going to look the exact same as a horizontal compression, and a horizontal stretch will look the same as a vertical compression. So we can't tell the difference between them from a graph. That's why trig functions like sine and cos were great ones to look at, because you could actually see which one was being moved. So what we do then is we just say, all right, discount B. Let's just talk about the A value. So we're really going to say g of x is equal to a x minus h squared plus k. The value we don't know is a, because we know the vertex. We know h is 2 and k is -3. And we actually can pick out a value on the graph. So we've got 1, 1. So that is an x value and a y value that is on this function. So if I substitute in for x and y in my general equation, and for h and k, the only variable left is going to be a. So we identify hk and 1 over the point, we got that, and substitute that in and solve for the a value. So instead of g of x, that's the y course, the output, I'm going to put 1. A, I don't know. X value, also 1 from the given point over here on the right, minus the h value, which is 2, all to be squared, and then the k value is -3. Now we just have to solve for a. So 1 equals a. Inside the parentheses, 1 minus 2 is -1. -1 squared is +1, so it's just going to be a 1 minus 3. All right, let's solve this thing down. So +3. So we get 4 is equal to a times 1, so 4 is equal to a. And then your final step is just to sub it back in and you're done. So g of x, we want the value of a in here. Now we're back to x because this is a function, remember, so we're back to general y, or the function, and general x, so that gives us the entire graph. Minus h, so minus 2 squared minus 3. And if you want to check it, put it in Desmos, see does it pass through those given points, does it look right, and so on. Always check your work. But looking at this, it's a vertical stretch of 4, translated 2 units to the right, 3 units down. So 2 units right, 3 units down, stretch of 4. And you can kind of tell here, over 1, up 4. This is going to be a kind of a cheat for you. If you go over 1 unit on a quadratic and find out what the height at 1 unit over, it will give you the a value. So think of it like a slope. So the average slope, the average rate of change when you go 1 unit over from the vertex. It doesn't work like if you go up another unit out here and then up, it's not going to give you your a value. It's only the first unit out from the vertex, and only quadratics. Okay, this one. Identify the type of function. This is an absolute value function. We got that V shape. It's upside down though, so it's opening downwards. General form. So we're only going with a value again. So we got g of x is a absolute value, x minus h, close the absolute value, plus k. So we got to solve for a again. Remember step 3 now, identify h, k, and some other value. So here's a point. So that's at minus 1, 2. And, sorry, that's the vertex. Another point, looks like the next coordinate I can tell is this one down here at 2, 0. All right, sub it all in. So we've got h, k, x, and y, or g of x, whatever way you want to write it. So 0 is equal to a, absolute value of x, which is 2, minus negative 1, because h is negative 1, plus 2. All right, so simplify that down. 0 equals a, absolute value of 2 minus 1, so plus 1, so absolute value of 3 plus 2. The absolute value of 3 is just 3. Remember, absolute value is the positive value, the distance from 0. So this will be 3a plus 2. Subtract 2 on both sides. So we get minus 2 equals 3a, divide by 3. So minus 2/3 is a. And we did expect it to be negative because it's opening downwards. So there was that reflection. We needed a to be negative. And then if we think of slope, minus 2/3 down 2 over 3. Notice that the a value actually matches the slope. And pro tip, it will be the slope from the vertex to the right. So not vertex to the left, that will be the negative version of it, or the negative inverse of it. And final step, rewrite our function. So g of x, sub in that new a value, back to x minus h, so minus negative 1, so it's going to be x plus 1, and then k value of positive 2. Done. Okay, your turn. So 3 different functions, linear, quadratic, and absolute value. The quadratic and the absolute value we just went through, so rewind if you need help with that. The linear one I threw in here because you did a lot of it in Algebra 1. I wanted you to check your skills. Can you still write the equation of a linear function just from looking at a graph? Pause the video, come back and see how you did. All right, welcome back. So linear function, if you have mx plus b, sorry, my pen went bad there, y equals mx plus b. Now this one only works if you can identify the slope and you know the y-intercept, which we do in this case. I can see the y-intercept is actually given to us at minus or 0, negative 2, and slope we can figure out by using the 2 coordinates that are shown to us. So we could say y is equal to slope, so we're going over 1, 2, 3, 4, 5, and then up 1, 2, 3. Slope, remember, is rise over run. So it's going to be up 3 over 5, so 3/5 x. And then the y-intercept is minus 2. Done. And as a function, that would be f of x as opposed to y. So if you're asked for a function, write it in function form. If you're asked for an equation, write in equation form. All right, quadratic at vertex minus 4, 6. So h is minus 4, k is 6, and the coordinate we're given is minus 2, 4, so x and y both given to us. So we've got g of x, a times x minus h squared plus k. Let's sub in our values. So the y value was 4, the x value is minus 2, the h value is negative 4, so it's going to be minus negative 4, it's going to be plus 4. Watch out for that, that catches a lot of people out. And plus 6, that double negative gets a lot of people caught up. All right, so minus 2 plus 4 is 2, so it's going to be 2 squared, which is 4. So we're going to have 4 equals a times 4 plus, I don't know why I wrote a 2, plus 6. Subtract the 6 from both sides, minus 2 equals 4a. Divide by 4. So a is minus a half. So I'll just I'll write my final answer up here. G of x, sub in that new a value, minus a half. We did expect that because it's opening downwards. X plus 4 squared plus 6. So even if you like draw a blank and you're like, oh, I cannot remember how to do this, at least sub in the h and k values. You know they're going to be given to you from the vertex. And then if you know that it's opening downwards, well, you know a should be negative. So if you're going to take a guess, make it a negative number at least. You know, if we go over 1 unit, so you go over 1 unit, you're going down half a unit. I don't know if you can see that from here, but there's your slope. So it was at minus a half. So that's your a value. You could have identified that just from looking at the graph. All right, final one is the absolute value one. H and k at the vertex, x and y given to us. G of x is a times the absolute value of x minus h plus k. So sub it all in. So y value 1, a we don't know, x is minus 2, h is 1, minus 3. All right, so we've got minus 2 minus 1, which is negative 3. But the absolute value of minus 3 is positive 3. So watch out for that. Absolute value will turn to positive. So 1 equals 3 times a minus 3. Subtract or add 3 to both sides. So we get 4 equals 3a. So divide both sides by 3. There's our a value. So a equals 4/3. So let's throw it in there. I'll go up here again. G of x 4/3. We got x minus 1 minus 3. Done. So now, can you look at it and identify the shape and the domain range? I threw domain range back in here again because it's going to pop up on your practice assignments for this. So let's make sure that we can do it. So when I'm looking at this, they're all absolute value. So we got V shapes going on. First question, which direction is the V opening? Is it up or down? If A is positive, it's going to open up. So over here, A value is not there, so A is just 1. So also positive, it's going to open up. This one, the A value is negative, it will open down. So we could say, okay, it's going to open up a value of 3/4. So that is a vertical compression. Because remember, it's between 0 and 1, so it's compression. So that's going to make it, a little bit wider. So instead of it being like a slope of 1, it's going to be a slope of 3/4. And the coordinate of our vertex, can you tell me what it is? So if x minus h, so minus h is 2, and then k is 7, so 2, 7 is my vertex. going to have a slope of 3/4. So it's going to go out 4, up 3, and then back 4, up 3 on the other side because it is symmetrical. And domain and range, so domain, we've got negative infinity to positive infinity. You can put this in a calculator if you want, but the challenge here is to try and be able to identify these just from looking at the equation. So the range, we know the range goes from the vertex up or the vertex down because it's going to go forever in one of those directions. Since the V is opening up, that means it's going to go from the vertex up. So 7 is going to be that lowest value. It's included because it's part of the solution. And it's going to go all the way up to infinity, not included. If you're asked for the end behavior, as x goes to positive infinity, y goes to positive infinity, x goes to negative infinity, y goes to positive infinity. All right, for the second one, a value is 1, so there's no stretch or compression vertically. There is a b value given, so a minus b value. So remember, if we have x, f of x minus x, it reflects it over the y-axis. So it's that horizontal reflection, which does not change the fact that it opens up or down. It's just going to flip it. So our b value in this case is 4, and it's technically minus 4. So it's going to have a horizontal stretch of 4. So that means it's going to be quite a wide v. So stretch of 4, the run got stretched. That means it's going to be over 4 for every 1 we go up. Coordinate of our vertex, minus h, so it's x minus h. If it's positive 1, that means our x value was minus 1, and then k value is just exactly what you see. So domain, I mean, they're all going to be minus infinity, positive infinity, because that's what all absolute value functions are. Range, it opens up from the vertex, so range is going to be from minus 3 to positive infinity. I made a mistake. It should be a square bracket because it's included. Last one, we already identified this one's going to open down. It has a minus, which controls the reflection, and then a whole number 2, which is greater than 1. So it is going to be a vertical stretch. So this one's going to be going down, and it's going to be quite narrow. So that'll be, over 1, down 2 kind of deal. It's kind of confusing. All right, the vertex. It's 3x, and there's no minus h. So what's the only value that h could be that would cause it to disappear? Must be 0. And then k value is 8. So 0, 8, going down with a slope of minus 2. So if we went over 1 and down, this would be what? 1, 6. So we could pick out a second point if we wanted to and draw. Domain. We've got negative infinity, positive infinity, both not included. Range goes from the vertex down. So the highest value in this case is 8. So the lowest value is negative infinity. Goes all the way up to 8, and 8 is included. Done. All right, next up is solving. So there's a couple ways to solve. We can solve graphically, we can solve algebraically. And thinking about the number of possible solutions on an absolute value function, like how many answers do you think you can have? So when you're asked to solve, you're typically, like, you've got an absolute value function and you're asked, okay, if I give you a y value, what are the values of x? What are the domain values that give you that answer? Or let me give you a value of x, what value of y do you get? So evaluate it. That one is less rare. The horizontal line is the one we usually care about. So we've got cuts it twice, 2 solutions. If it goes through the vertex, you only get 1 solution. And if it doesn't touch it at all, 0 solutions. You should remember this from Algebra 1. With quadratics, it was the same thing. There was 0, 1, or 2 solutions. Forgot I was putting text over there. All right, so here's our example. We've got function up top, minus 5x plus 1 plus 2, minus 5 absolute value of x plus 1 plus 2, and 3 different questions. So the first one is, if f of x equals 12, what is the value of x? So if the answer, the y value, is 12, what would the x value be to get that? And it's values slash values, because there could be 2, there could be 1, there could be 0. F of 6, we're saying x is 6, what is y? Since it's a function, there should only be one answer, because that's the definition of our function. For every value of x, there's only one y value. And then the last one down here, they give us the y value. It's almost the exact same as the first question. And they're asking, okay, for what value of x, or values of x, is the answer going to be minus 3? Is there going to be a y coordinate of minus 3? And you got to solve it. So if we're going to do this graphically, you do it using the graph. And if you do it algebraically, we're going to do it using math. Let's take a look at the graph first. Let's take a look at a couple of different ways that we can solve an absolute value function graphically. So in the example you were given, the function was y equals minus 5, x plus 1 plus 2, and it was an absolute value on the x plus 1. You can see the graphical representation of the function on the screen. So it's opening downwards. It's a very steep slope. It's a slope of minus 5, and the vertex is at negative 1, positive 2. And the first question was, well, what is the value of x when y is 12? So if I put in a separate equation, y equals 12, and you can do this in your graphing calculator too. So you make a new line, or go to y2 line and put in 12, and we're going to see where those lines intersect. So I'm going to turn on y equals 12. We can't see it because y equals 12 is up, so I'm going to zoom out a little bit. And y equals 12 is never going to intersect this absolute value function because it's opening downwards. So the end behavior is it's going towards negative infinity in both directions. So it's never going to come up and hit 12. So this is one of the situations where there is no solution. So if you were asked, when does the absolute value function of minus 5, absolute value of x plus 1 plus 2 equal 12, you would say never, no solution. The next one was, what is the value of y when x equals 6, or it was f of 6. So we're going to substitute in 6 for x, or we can do a line at x equals 6. This one you cannot do in your calculator, but you can do it on Desmos. So we get that vertical line at x equals 6. I'm going to change color on that just to show you it's not something that we're using. And we want to know where it intersects with our graph. So we come down here, there is a solution, and it's a single solution, so one solution at 6, negative 33. So we would say if we substitute in 6 for x, the answer would be negative 33. All right, then the third part was when x is, or when y is minus 3. So if we substitute in minus 3 here and we have an equation, we're asked to solve for x, we're really being asked for what value of x is the answer minus 3. So we can go with that graphing idea again of doing a separate equation at y equals minus 3 and seeing where they intersect. So on your calculator, you're using the intersect option. So it's second function, trace, and then intersect. On Desmos, it's so much easier because Desmos highlights the points for us. We can see the red line coming through, cutting through the absolute value function in 2 spots. So there are 2 solutions to this one. Should remind you of quadratics when you did that back in Algebra 1. And the 2 solutions are when x is minus 2 and x is 0. And in the next slide, you'll see how we solve these algebraically. We'll get the same answers, but just to kind of show you that it can be done very easily using visual representation. Be careful though, if you're doing this in a test, just saying the answers may not be enough. You may be asked like, how do you know? Or you need to sketch a version of the graph as well. And they're looking for accuracy in your graph. So make sure you are using the tools you have, but also answering the question you are asked. Finally, I just want to demonstrate when there's one solution. So the only time there will be one solution when you're substituting in for y is when the y value is the same as the vertex. So at the vertex, there is only one point that has a y value of 2. Every other y value, it's either going to have no solutions because it's above the vertex, or it's going to have 2 solutions because it's somewhere else on the absolute value function, and every y value is going to have 2 domain values going through it just because it is that V shape. So it goes up, hits a turning point, comes down, or has the upward V value. Okay. So the next one then is solving algebraically. So if we want to solve it algebraically, we're going to figure out what we're being asked for and then go with that. So the first one is going to be f of x equals 12. So when is the y value 12? So the answer is going to be 12. So over here I would say 12 equal to minus 5 absolute value of x plus 1 plus 2. So we would subtract the 2 from both sides. You're solving this like a normal equation. We're trying to get the absolute value part on its own. So we get 10 equals minus 5 absolute value of x plus 1. Divide by minus 5 on both sides. We get minus 2 is absolute value of x plus 1. Now there's a problem here because anything inside of an absolute value function will result in a positive answer. So it is not possible for the absolute value of any number plus 1 to be negative 2. And that's why on the graph we weren't able to get a solution. The line was way above our actual function. So we would say no solution. This is question 1. Question 2 asked us when x is 6, what is the output? So what is f of 6? So 2, f of 6, you are doing minus 5, absolute value of minus 6 plus 1. So we're subbing in that minus 6 where we had an x. I'm sorry, why did I do minus 6? Positive 6. So f of 6, positive 6 in there, and then plus 2. So 6 plus 1 is 7. Absolute value of 7 is still just 7. So it's going to be minus 5 times 7, which is negative 35. We'll get to that in a second. So f of 6 is going to be minus 35 plus 2, which is negative 33, which is what we saw on the graph as well. Thirdly, I don't know if that's a word or not, but we're going with it. Thirdly, minus 3 equals minus 5 times absolute value of x plus 1 plus 2. So what values of x will result in a y value of minus 3? And we know there are solutions for this one. So minus 2 on both sides. So we get minus 5 equals negative 5 times absolute value of x plus 1. Divide by minus 5 on both sides. So they actually cancel on both sides, but remember we're left with a positive 1 when we cancel using division. So 1 equals absolute value of x plus 1. So now the answer is positive, which is great. That's what we want. What could be inside of here is either a positive 1 or a negative 1. So whatever x plus 1 is, if it adds up to be positive 1, the absolute value of that will be 1. If it adds up to be negative 1, the absolute value will still be 1. So there's two possible tracks here. So that means we've got x plus 1 could equal positive 1, or x plus 1 could equal negative 1. And we have to solve both of those. And that's why there's two solutions. So minus 1 on both sides, x is equal to 0. Minus 1 on both sides, x is equal to negative 2. And those were the two solutions we found in our graphic version as well. So even if you are being asked to solve it algebraically, it doesn't mean that you can't throw it into something like Desmos or your graphing calculator and just check, hey, am I right? Or what should my answer be? And then get your math to match up with that so you'll know if you're on the right track very quickly. Okay, it is your turn. Off you go. Pause the video, come back when you are done and check how you did. Okay, welcome back. So first one, 4, that's our y value. We're being asked what value of x or values of x results in a y value of 4. So it's going to get a little messy, but we'll go with it. So plus 8 on both sides. We got 12 is a half absolute value of x minus 2. How do you get rid of a half? You multiply by 2 over 1. You're multiplying by 2. That's the inverse of a half with multiplication. So it'd be 24 is equal to absolute value of x minus 2. It is positive, so that means there are solutions. And it looks like there's going to be 2 solutions here, because if it was 0, there would only be 1. All right, so we've got 24 is equal to the absolute value of x minus 2. So that means whatever's inside of the absolute value, the x minus 2, it's going to equal positive 24 or negative 24, because if it's negative 24, the absolute value will result in a positive 24 answer. So we add 2 to both sides. In both cases, x is equal to 24 plus 2 is 26, minus 24 plus 2, minus 22. So there's my 2 solutions, 26 and negative 22. Second one, we were asked for f of 2. So remember, that's our x value. So what's the y value when x is 2? So all we have to do is sub in 2 for x. So f of 2 is going to be minus 3, absolute value of negative a third, times 2 plus 4, close the absolute value, minus 9. All right, so 2 plus 4 is 6. 6 times a third is going to be 2, and it's minus thirds, so it's going to be minus 2. So let's take a break there and write down what we got. So minus 3 times minus 2, and that should be absolute value, not a parenthesis. So we get absolute value of minus 2 and then minus 9. Absolute value of negative 2 is positive 2. So it's going to be minus 3 times positive 2 and then subtract 9. So that will be negative 6 minus 9, which is negative 15. So f of 2, when x is 2, y value is going to be negative 15. Third one, I'm going to do that on the right over here. So this will be number 3. We have f of x again given to us, and if the answer is negative 3, what's the value of x? So subbing in for f of x as being negative 3, we got 3/5 absolute value of 2x minus 4. So what they did was they distributed in, no, I say they because I pulled this out of the textbook, they distributed in the b value to the parentheses. So you could pull it back out again to figure out what b was, but that's not what we're being asked for in this case, so it doesn't matter. All right, add 3 to both sides. Get 0. 0 is equal to 3/5 absolute value, 2x minus 4. To get rid of the 3/5, we're going to multiply by 5 over 3 on both sides. Cancel that out. And 5 over 3 times 0 is 0. That's why I was crossing it out. I was getting ahead of myself. So we're left with anything times 0 is still 0. 0 is equal to the absolute value of 2x minus 4. Now the only way for that to happen is if what's inside here is equal to 0. So there's only one solution in this case. 2x minus 4 is equal to 0. So 2x is equal to positive 4, so we'd add 4 to both sides. Divide by 2, x is 2. So that would technically tell us that the vertex of this function would be at 2 minus 3. Because that's the only solution. So it's the only value when the y value is minus 3. All right, there was a lot in that today. So essential questions: how do I write the equation of a quadratic or absolute value when given a graph? You identify h and k, one other point in the graph, x and y. You sub those into the general function and solve for the a value. So that is the vertical stretch or compression. Once you find it, you rewrite it by subbing in for a, h, and k. Put x and g of x, or x and y, or x and f of x back where they belong. Steps involved in solving. You can solve graphically or algebraically. If you're solving algebraically, which is the one that I think we need to worry about the steps, are you solving for x or are you solving for y? That's the first question. And then making sure that when you get to the part where you've isolated the absolute value part, that you allow for the positive and negative version of the answer. If you have absolute value of something is equal to a negative number, there is no solution. All right, after today, you have reached the end of Module 2's content. So complete that, end of this folder, the absolute value functions and equations. then your math tasks, and your module assessment, and then you'll have a unit assessment as well. So wrap all that stuff up, get it done, put a bow on it, and we'll move on to Unit 2 next week.